All right, we are on the got it problem number 3, and you had to do a proof. So we're back to the 2-column proof with our statements and our justifications. And I have line MP is parallel to line AC, and that is given. Then these next 2 lines you could do in different order. But I see, because these lines are parallel, I'm going to draw out the picture. I have AC parallel over here to MP. And I have this line CM passing through the transversal. So if these lines are parallel, I can say that my angle that is formed there, angle C and angle M, angle C would be congruent to angle M because those lines are parallel. Why? Because those are considered alternate interior angles, and it comes from that theorem, alternate interior angle theorem. If we have 2 lines that are parallel, the alternate interior angles that form are congruent. Okay, then I'm going to look at this line here. I'm going to look at a different line. And now I don't want blue. Let's choose green. So now I'm looking at this transversal passing through. If these lines are parallel, I can also say that these alternate interior angles, alternate interior angle theorem, that angle A would be congruent to angle P. So now I have in my picture, I have 2 sets of corresponding angles congruent. So I can go ahead and say triangle ABC is congruent to triangle PBM by AA similarity. And it's done. Maybe you decided to look at and choose the vertical angles being congruent by the vertical angle theorem. And that's fine. Maybe you picked 1 set of alternate interior angles and the vertical angles as your 2 corresponding angles congruent. And that's fine to do as long as you just didn't say angle B is congruent to angle B. It would have to be a 3-letter angle because it could be any of these angles that you're talking about, so you have to be more specific. All right, and got it problem number 3, part B. It asked for the figure, suppose you're only given that blah equals blah, could you prove that the triangles are similar? Well, let me draw out the picture again. It sort of looks like it. And it tells us that CA goes with PM, just as CB goes with MB. So we have 2 sets of sides that are proportional. Could I say these 2 triangles are similar based on that information? Well, the only other information that I could get from this is the vertical angles. And what I'm noticing is the vertical angles are not included between the 2 sets of corresponding sides that are proportional. So I could not say side angle side because the angle is not included. So can I just say side-side similarity? No. The only one is side-side-side similarity, and I'm not given that information, and I wouldn't be able to prove that. So no, I could not prove that they are similar. All right, there is one other feature to this section, and it's known as indirect measurement, another vocabulary term. And indirect measurement is going to make use of similar figures to find unknown lengths. And you would use indirect measurement with things that are difficult to measure directly. So if you're like Ella, who's Miss Rock Climber, I just thought of that because that's the example they show in the book, and I saw her in the paper for rock climbing. She's looking out at Hartman. She's looking at this rock that she wants to climb. Now this looks like a guy in here, but we're going to pretend that it's Ella. Okay, Ella. And it says that this is Darius but it's not. It's Ella. So I'm going to cross that up. Come on, let me write. Let's see. There we go. We're saying it's Ella. Before rock climbing, Ella, there she is. Are you 5.5 feet, Ella? We'll hope. Okay, there she is with her long hair. Ella wants to know how high she will climb, and she wants to climb way the heck up there. Man, Ella, you should have other people out there watching you. Okay, don't climb this. Anyway, she decides she's going to do it anyway, but she's going to do some math first. Of course you would, Ella. She places a mirror on the ground right there and walks backward. She's using her math skills, similar triangle skills, to see if she can figure out how high she's going to climb. Walks backward until she can see the top of the cliff in the mirror. And what's so cool is from that mirror, we're able to form two, hold on to that thought, two similar triangles. And you get, okay, I'm back. That was Ella's parents saying, don't climb that rock. You should have your coach out there. Just kidding, it wasn't. All right, what is the height of the cliff? So I said we have two triangles that are formed that end up being similar triangles. Why? How could we prove it? Well, we have 90-degree angle set, and because of the mirror, we have these two angles that we can say are congruent. So these triangles are congruent by AA similarity, and because of that, we can find the height of the cliff, because we know, since they're similar triangles, that their sides are in proportion to one another. So I would set up a proportion here. So I would say X relates to 5.5, because that's how tall Ella is. Probably not. Just as 34 relates with 6. And they're all in feet, so I'm good. And then I go ahead and solve this. The way I'm going to do it is by using the product of the means and extremes. So I'm going to look here. And I have 34 times 5.5, and I'm at 187. And that equals the product of 6 and x of the extremes. Divide by 6. And uh-oh, Ella, you are climbing a cliff that is 31 point, I'm going to approximate here, 31.2 feet high. Whew. Okay, and that's just using similar triangles, what's known as indirect measurement. Now you know, Ella, rock climbing. Get that mirror out. Okay, I will see ya soon. Actually, what I do want to tell you is to not just do nothing right now. At this point, you need to go to Gunnison Math and see what problems that I gave you guys. Okay? Gunnison Math, find those problems for section 7.3 and start on them. Okay? And maybe finish. And know that that is due Monday at the beginning of class, so I can check and see if you're on track. All right? Enjoy the weekend. See you at the dance if you're going there, because I am chaperoning. Yep. Oh no, please no. My computer, that was it, my computer. I just made that whole video. I don't want to have to do it again.